on the physics foundation paper. So let's see what information we're given to start with. Figure 6 shows how the mean power output from solar and wind energy resources in the UK varied between 2014 and 2019. So figure 6, which is your top graph, your bar chart here, got mean power output, okay, on the y-axis, and along the bottom you've got the years 2014 to 2019. You've got solar power and wind power. Underneath that, figure 7 shows how the power output from solar and wind energy resources varies in a typical year. Again, we've got power output on the left hand side, which is your y-axis, and then we've got a typical year from January to December, and we've got wind and solar shown on that graph. Our question: explain the changes in power output from solar and wind energy resources between 2014 and 2019. Should include an explanation of the change in power output during a typical year. 6 marks. Right, first bit when I mark this, most people described and didn't explain, which means you've described what's happening in the graphs and the trends, but you've not given a reason. Okay, I've seen some really good answers, but with no explanation, the maximum marks you can get is 2. You need the explanation to get your higher marks. All right, so your full marks. So let's split this into two parts: the top part and the second part. So this top part, explain the changes in power output from solar and wind energy resources between 2014 and 2019. So we're looking at figure 6 here. So we can see, looking at the wind power, the light grey, it's increased from 2014 to 2019. So the power output is increased. Okay, a reason for this, because maybe more wind turbines were built. Equally, solar power, so the dark grey, has also increased from 2014 to 2019. Again, a reason for this, because more solar power panels were built. Okay, so straight away, not only describe what's happened, we've give a sensible reason. More wind turbines built, more solar panels built. Okay, power output increased for both. Because I've also said the power output from wind and solar may have increased due to climate change, which is also a valid reason, but for me less obvious, so we'll stick with what we've got so far. Next bit, we look here from 2015 to 2016, we can see the wind power has dropped or decreased from 2015 to 2016, and then begins to increase from 2016 to 2019. Okay, so again, a reason for that, we could say, typically, most probably, is because 2015 was a windier than 2016. So again, it's just giving a description of what's happening in the graph, a sensible reason. So wind power was lower in 2016 than 2015 because 2016 was less windy than 2015. Okay, let's move on to the second part of the question. You should include an explanation of the change in power output during a typical year. All right, this bit now. So we're looking at figure 7 for this. We can see that most of the year, the electricity generated from wind is greater than that of solar. So if we look at the solid line, we can see most power has come from wind rather than solar. That will give us a mark. We can also see that electricity generated from wind is greater in the winter, so sort of January, November, December time. And again, a reason for that, because winter's windier than summer. All right. Also, we can say that electricity generated from solar is greater in the summer, which is sort of here, May, June, July time, because the hours of sunlight are longer in the summer and because the intensity of the sunlight is greater in summer. Okay, so we've got a number of points we can look at there. So add them in. That will give us 6 marks. Okay, 3 from the top, all with descriptions and explanations as to why. 3 from the bottom, again, with descriptions and especially these last 2, explanations as to why. Okay, that will give you 6 marks. So remember, if it says explain, you need to explain why.